Alright, so for 4.3, we're going to start off with trigonometric function of any angle. Now, reading from the textbook, here it says that in lesson 4-1, basically 4.1, the definition of the 6 trigonometric functions were restricted to positive acute angles. In this lesson, these definitions are extended to include any angles, so positive and negative angles, meaning that if we're in the unit circle, angles from the first quadrant, so quadrant 1, top right section, quadrant 2, top left section, quadrant 3, bottom left section, and then quadrant 4, bottom right section of the xy plane. So let's talk about the trigonometric function of any angle. Now the concept is defined as let theta be any angle in standard position and point P of x and y, a coordinate point, to be a point on the terminal side of theta. So what it means, just like how we taken notes in 4.2, standard position will always be the right side of the x-axis. That's where the angle is graphed. That's where it's going to start. Terminal side is when the angle stops. So here, where the angle stops rotating, that's where it's a terminal side. So here we have point P, x, y. Now, continue with the concept. It says let R represent the non-zero distance from P to the origin. So from P to the origin, that's the length of R, or radius. Or from origin to point P is also represented again by R, which usually known as the radius, and you will see why I'm using the word radius when it comes to the unit circle. Now continuing with the concept, it says that is let R equal to the square root of x squared plus y squared while not equal to 0. So if you were to remember from Algebra 1, this seems very similar to the distance formula. So keep that in mind when we will talk about distance formula in Chapter 7, conic sections. So continuing on, then the trigonometric function of theta are follows. Sine theta equals y over r, or y divided by r. Cosine theta equals to x divided by r. Tangent theta is y divided by x, while x does not equal to 0. Now the reason we define that x does not equal to 0 is we cannot have 0 in the denominator. If you do, you will see in the calculators, if you were to divide by 0, it will say errors or no real solution. But to tie in from the previous lessons, the previous math classes, when you have a 0 in your denominator, it's called undefined. So that's why it is defined here or declared here that x does not equal to 0. Now moving on to the rest of the functions, cosecant theta, CSC, is equal to r divided by y, where y does not equal to 0. Secant theta, r divided by x, where x does not equal to 0. Cotangent theta equals to x divided by y, where y does not equal to 0. Now, how come these three functions where it's declared that y and x cannot be 0? Because we see that x and y are in the denominators, versus over here, how come r was not declared as not equal to 0? So tying this is related to the Pythagorean Theorem, where a squared plus b squared equals c squared. If one of them is a variable or a known value, while you're not given the other one, you can still have a value for r. Now the opposite, x and y, is not the same. The concept is not the same in reverse order. Now, in a unit circle, there's going to be some times where x and y can be 0, and if in the event it is 0, then if y is 0, then there is no value for cosecant. It's undefined. If x is 0, then there is no value for secant. It's undefined. Same thing with cotangent. If y is 0, then there's no value for cotangent. You cannot find one. That's why it's going to be called undefined. But you will always have a value for r, which is why you will have a value for sine, cosine. But same thing with tangent. If x is 0, it will be undefined. So that's basically the concept of trigonometric function of any angle. So again, as you can see, it's going to be a right triangle, and you would use Pythagorean Theorem to find r. So this is basically how it would look like when you're given an angle. You draw a triangle, use a point, but later on you'll see the connection to the unit circle.